Hello learners, and welcome to our first video about transition metals and coordination chemistry. Okay, so before we get started, I wanted to remind you of the pre-lectures, one-pagers, and the previous information section. So of course you want to go to the pre-lecture area, and you want to complete the pre-lecture one-pager to orient your brain with the information. Now, if you are having trouble connecting those smaller details with the material, no worries. You can always check the previous chapter information area, which is right here, and of course, identify areas that you might have found confusing, and then just go back and review and complete practice problems of that particular concept. This is a great solution to remedy that issue. And of course, the goal of lectures is just to enhance or add to the pre-lecture information, so this all connects. And finally, I do want to say, do not forget about the post-lecture, folks. The homework has its own goal, just like the textbook exercises and the practice exam, and all is there to help you get this work done, okay? So the homeworks will be taking the lecture material and providing examples, and sometimes goes a tiny bit further to challenge you. Of course, you have textbook exercises for more practice, really, and it also provides what you need to really go over the textbook information. So that kind of connects back to that one pager. And of course, the practice exam gives you a framework of what you need to know and the type of difficulty of questions. But the overall goal here is just to organize yourself with the work and try. Even if you fail or you don't get it, go back and try again. I mean, we have these videos here for you to be able to re-watch them as much as you need, and for you to be able to re-practice the work as much as you need as well. Okay, folks? Now let's go ahead and get started. Welcome to America's Next Transition Metal, where we get to learn about transition metals, their compounds, and their chemistry. So these elements, which will serve as our models, are vying for the title of the most versatile and captivating participants in the chemical universe. So we will first learn more about the atomic, physical, and chemical properties of these elements so that we get to know our contestants. Next, we will see firsthand how transition metals form the coordination compounds with ligands and create their own geometry and hybridization. And finally, we get to be the judge and explain how all these properties of transition metals exist through a new theory called the crystal field theory. So with so many different compounds that can be formed, transition metals are a part of so many everyday reactions like photosynthesis and fat metabolism and processing. I mean, it's what our cell phones are made of, okay? Also cutlery. You think of jewelry, paints, transportation. So it's no wonder it's important to get some details about all these different transition elements, right? So let's dive into the runway of the periodic table and explore the exciting chemistry that unfolds, folks. We can't get into every transition element in this course, but we can begin to dive into some general properties that transition metals share. So first, location. Transition metals are found here on the periodic table, okay, in the D block on the periodic table. So this is going to give rise to different atomic, physical, and chemical properties, just like we saw with those metals and non-metals, because based on where you're located on the periodic table, some different properties can arise. So let's think electron configuration. We think electron configuration and filling out those orbitals, okay, for like atomic properties. And when it comes to our transition metals, we are focused on those d orbitals and filling out those d orbitals for electron configuration, okay? And when we're thinking of like atomic size, ionization energy, electronegativity, those are some physical properties that are going to be based on whether or not electrons exist in these orbitals. And then, of course, we can go further and think of oxidation states like reducing power or strength, color, and magnetism for those chemical properties based on how those electrons are filled in those d orbitals. And we'll talk about that as we go along as well. So we know that if you go across a period, let's go ahead and go across a period here. You go across a period, this is going to start with period 4 here, because we're looking at the periodic table and they're kind of taking out the D block for transition elements, and also the F block, which are going to be our inner transition elements. Can't forget about those as well. We'll talk briefly about them too. So if we go across a period on the periodic table, okay, and of course, if we go within a group, we can go up a group or down a group. We kind of expect that there's going to be similar chemical behaviors because we saw that with the metals and non-metals from Chem 101, right? But that doesn't always, it's not always necessarily the case, basically, with transition metals. So all we can do is basically go off the new trends that we can come up with and then try to follow those trends and just watch out for exceptions. Because with transition metals, because they're so different and there's so many different compounds that can be formed, there's a lot of exceptions that we can come across, okay? So what else? Well, transition metals certainly behave like typical metals. They have that metallic luster, which we'll see later on. They have high electrical and thermal conductivities, okay? So that means that because they're very similar to transition metals, you won't see any transition metals kind of being non-metals, for example. Talking about transition metals are all going to be metal based. Okay. Also, we know that they can display variations in physical properties. So if you're thinking like melting points, the transition metals as a whole have very huge varying in melting. Like tungsten can have like 3,400 degrees Celsius, and mercury only like 25 degrees Celsius. Okay, so tungsten and mercury. Same period, but very range in the actual temperature. Also, we have differences in strength. Like some of them, the transition metals can be very hard and strong, whereas some of them can be like very, very soft, like gold, very, very malleable. We also have variations in chemical reactivity. And one cool example are the oxide. So oxide means you have a compound that contains oxygen. So basically you're saying something that could be like a polyatomic ion or some kind of complex ion, or even a coordination compound, which we'll talk about later, or basically be anything that actually has oxygen within it. So sometimes you can have little transition metals like chromium or nickel or cobalt. They actually create these oxide compounds and they form variants. So we'll see how chromium is good for like auto detailing because one, yes, it looks luxurious, but it gives like a protective coating over the metal of the car, right? But we also have other oxides that are formed with transition metals like iron, okay? And iron oxides actually form rust. And so what happens is you'll form this huge layer of rust, and then that layer will crust off. So it kind of is forming some kind of layer, but the layer ends up crusting off, and then that means you're exposing more of the actual metal again as well. So because of that, you do see that with rusting, or like if you have anything that's rusting off, you'll see the rust will fall off, then it'll expose it again, rust again, fall off until you really have nothing left over. So there are so many ways to really organize yourself with even this bit of information, or say like a flashcard. On the front, you can write transition metals. On the back, probably 2 to 3 facts. And as we continue on, that's really the goal you want to be doing. As we see flashcard moments throughout this entire lecture, always remember to stop yourself. Sometimes I won't actually tell you, so you want to just start recognizing them, being like, oh, it's a flashcard moment here. Let me go ahead and stop and figure some things out. Okay, other things to note about transition metals. First, they have variable positive charges. Okay, variable positive charges, and oxidation states. But that also means that they are definitely more controllable and they're easier to engineer. Okay. They're not as reactive as the main group metals, but they're definitely reactive enough. Some oxidation states are going to be way more stable than others, and they become the ones that are more common in compound. Okay. Transition metals are also found in ores. So ores are going to be like basically your rocks or minerals. And so these rocks or minerals can contain transition metals, and the goal is to extract those transition metals and then, of course, use different chemical processes to refine them and, of course, heat them up to the necessary amounts. And we'll talk a little bit about that as well. They also can form different types of ionic compounds. So they can form, of course, ionic compounds from your typical cations. Let's say Ti3+, Mg2+. Okay. They also can form hydrated ionic compounds. So let's just say we have our manganese here, CO2, 4H2O. So this is a hydrated compound that has the transition metal manganese. They also can form polyatomic ions, of course. Like, let's think dichromate. So this is a polyatomic ion, dichromate, so it has chromium here, which is a transition metal. It also can form complex ions, and that's what we're going to learn about as well. Complex ions, you have like your cobalt attached to different ligands, okay, that also have a charge attached to them. And we're going to be talking about those as we go along. Let me go ahead and rewrite that. That's NH3. Okay. Now, outside of just these ionic compounds, they also can form coordination compounds, and we're going to talk about those later. They can form coordination compounds, which are pretty cool because these coordination compounds are bonded to different ligands, kind of like what we see here. And these different ligands can be manipulated as well. So you can also now start controlling structure and, of course, properties of different transition metal compounds just because you can then manipulate, going back to the fact that they're controllable and engineered. Okay. They also can undergo redox chemistry really easily. So because they can undergo redox really well, meaning they can lose electrons and gain electrons really easily. So they're normally going to be really good catalysts as well. So think of platinum in your catalytic converter in your car or something like that. The goal is that it's not going to be used up, right? You can use it as many times as you need, and it's not going to run out because it's able to go through that readout process and lose and gain as much as is needed. And so when something is in a chemical reaction, it doesn't get used up, it's called a catalyst. Okay, folks? And also it has many other applications. I mean, not just to cars and things like that, but also to biology and other industries. So I always think of the anti-cancer drug, okay, cisplatin. And this is basically an anti-cancer drug. You can think of that for transition metals and how it affects different industries. You also can think of like sunscreen, I mean, cosmetic industry, batteries, okay? Not just for batteries for your car, but also think for flashlight, things like that. Also down to biological, other kind of biological effects of transition metals, like the fact that iron is a part of heme groups. And those are the groups that actually carry oxygen through our blood so that we actually can live. Okay, so there's a lot of different ways of why transition metals are important. Of course, we're not going to be able to go through every single tiny detail of everything, but the goal is that we're trying to organize ourselves to help us understand what transition metals are, why they're important, and of course, make it a little bit fun by thinking of them as all these different models that come with all these different kind of values and basically looks and colors and things like that. Okay, folks? So let's continue on.